Hi guys, welcome to this video lecture of mechanics of automobile system. This is Dr.M.MOORTHI, working as assistant professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So in this video we are going to discuss about a topic called free body diagram. So in this previous lecture videos we have discussed about what is the force system and what are the types of forces acting on the system, and then what is static force analysis, what is the dynamic force analysis, what kind of forces acting on the system, while the force acting on the system, what are the changes happening in the system. So these things we have already discussed. And the next this is the free body diagram. So this free body diagram is, the definition is a separation or the definition, exact definition is the separation of the object or isolation of this object from the surrounding object or supporting object. So this is the definition. See here, a free body diagram is a sketch or a diagram of a part is to be isolated from the mechanism in order to determine the nature of forces acting on the system. So what is the objective of to draw the free body diagram is to determine what are the different types of forces acting on the system, and what are the changes by the application of the various type of forces. And the next see here an example of 4-bar mechanism. So here we have 4-bar chain, and we take as the link 1, 2 and 3, and link 2 is the crank and it is the rotating element. And see, the various forces acting on each member is to be listed. And so this is the free body diagram of this 4-bar chain, and it starts with the first one. It is the link 2, it is the crank, and the forces is acting from link 3 to 2, that is the from link 2 from 3 to 2 means, and we indicate the direction called F3 to 2, and it is direction is parallel to link 3. And similarly, if we consider the static equilibrium and equivalent and opposite force, but this force is parallel to F3 2, but it should be in the opposite direction, so that the system will be in the or remain in its the state of static equilibrium condition. And we go with the link 3, and from the link 2 to 3, and from 4 to 3. So these are the forces and equal and opposite forces on the link 3. And at the end of left end of the link 3 means F23, this force, that is the force acting from link 2 to 3, so it indicates F23. And from link in the right side we take the forces or the force act from link 4 to 3, so it indicates F43. And next we have link 4, and this force is parallel, that is the force is acting from link 3 to link 4, so F34, and the equal and opposite force F14, so that the system in equilibrium condition. So this is the 4-bar mechanism is indicated, and what are the forces acting on the 4-bar mechanism by each link is listed here. And the next one is the slider crank mechanism. Similarly, we have crank and connecting rod, and this is the free ball diagram, the diagram of slider crank. Yes, we have we know this crank is the rotating element, and it have it also produce the torque, and it have the equal and opposite force F32 and F12, and similarly connecting rod, and we have a slider. So next one is the equilibrium condition. So yes, we have previously discussed the talk called the static equilibrium. So yeah, body is in static equilibrium, and if it remains in its state of rest or motion. And so this is static equilibrium. If the body is at rest, it tends to remain at rest, and if it is in motion, it tends to keep the motion. So it keeps the original action, whether it is in the static or in motion. So the condition is summation of F equal to 0 and sigma sigma t equal to 0. So next one is a dynamic equilibrium. If the body is in motion, it tends to keep in motion, and it simply that the velocity do exist but remain constant, that system in dynamic equilibrium. Yes, the system is in motion, but at the end the forces acting the system are assumed to be equal, or is zero. So sigma fx is equal to 0, that is the force acting in the horizontal direction is 0, and the y direction is 0, and it is the rotation, or we take it as a moment, is equal to 0. So this is the equilibrium conditions. And different that is the equilibrium of 2 and 3 forces system. A member and the action of two forces will be in equilibrium if the condition is the forces are of the same magnitude, the forces act along the same line, the forces are in opposite direction. Yes, it is in the same line, that is the same line, but it is in opposite direction, that is similar line of action. The forces should be acting in the same line of action, but it is in the opposite direction. And a member under the action of 3-4 system, the condition is the resultant of the forces is equal to 0, and the line of action of forces intersect at a point, and it is known as point of concurrency, and it remain its a state of equilibrium, equilibrium conditions. Thank you.